8 degrees would give you an extra 5.4 horsepower. What is up, guys? Welcome to JS Racing. My name is Jason. So a while back I did a bunch of testing with ignition timing, and I have to say the results are quite incredible because before then I really never tested any changes to the ignition timing. So when I finally got the dyno, I decided to give it a try, and yeah, as I said, the results are quite crazy. So I'll show you the data real quick now. So I'll just open up the original ZR16 engine dyno test. So this in the previous video it actually shows as ZR22, but I changed the engine name now to ZR16, but it's still the same data because we're sort of now redoing all of the engine numbers to correspond to what sort of horsepower it can do. So ZR16 is really for around 16 to 18 horsepower. So that's the reason for that. So this data is still old data because there are a couple of changes that we will be applying to the ZR16 that will push it to around 17 to 18 horsepower. Anyway, so let's open up the first test. So I did two tests. One is a 4-degree change to the ignition timing, and the other one's 8. So I'll show you the 4 first. So when I first saw this, and mind you, I ran the settings 3 to 4 times on the dyno, and it's pretty much coming out at the same number. And I thought that's pretty weird because shouldn't it be at least above the original timing? Because it's 4 degrees. It should be closer to the ignition point, right? So I don't know. It shows up as very, like, I don't know, baffling. So I don't know if this data is corrupted or I did something wrong with the timing. But yeah, it just doesn't seem right, at least to me. So 1.1 horsepower less. That's really weird. So I thought, okay, maybe I need to push it to 8. Mind you, I'm using stock cam. I don't have any other cam, so I'm just using the stock cam. Anyway, so I changed it to 8 degrees, and then let me just show you the data overlaid on top of these. And when I saw the result, I was like blown away. I'm like, 8 degrees would give you an extra 5.4 horsepower. That's crazy. And I ran it a couple more times. The second time it came out to around the same number. It's like 20.3, 20 point, yeah, it was 20.3 or 20.2 or something. But then I ran it a couple more times. It went lower and lower and lower. And then I thought, okay, something's really wrong with the engine because it felt like it took a long time to really hit the highest RPM. So I decided to take the engine apart and just see if there's something wrong, because previously when we had similar problems, it was either the cam got eaten away, or either the piston was like leaking or something. So I took everything apart because the engine is sort of like the one engine that I use to test all my settings. So I've been using the same engine the whole time. Although I do have several engines in my garage, I've been only using one because I want to maintain all the variables as the same. So if there's any changes, I'll only make it to this engine. Anyway, so I took it apart and I realized that the push rod was bent. So looking back at the data, I'll just open up the data again. All right, so I'm showing you guys the data again, but this time I'm overlaying everything against time. So on the x-axis is time on the bottom, and then on the top it's the torque, the power, and RPM. So after seeing this, I realized the core problem why the push rod was bent so quickly, even after just 2 or 3 runs. If you look at the front, there are 2 peaks. The solid line is the torque. The dotted line, the second peak, is the power. And then the third one is the RPM. So let's just look at the time. If you look at the top, okay, ZR16 original exhaust, 8 degrees. It took only 0.77 seconds to reach 44 Newton meter worth of torque. That's insane. So that means every time I pull on the throttle to wide open, it's pulling that much torque instantly, putting that much pressure onto the push rod to get that insane amount of horsepower. And that's crazy. So let's look at the original engine. If you look at the solid line and then you compare the dotted line with the little tiny dot and the long dash, it doesn't reach the peak torque until at least 2.0 seconds, 2.09 seconds. But in terms of RPM, it's around 2,700 at peak torque. Whereas for the 8 degrees engine, it's instantly at peak torque at around 2,509 RPM. I mean, that's crazy. So, I mean, after testing all these changes to the ignition timing, there are a lot of mixed feelings because the first is the 4 degrees. I thought it would be at least above the original setup, but it's 1.1 lower. So I didn't understand that. So if there's anyone who's tried that, please let me know if there's something I could possibly be doing wrong. And the second thing is with the 8 degrees, it's just, I think the power increase, it's crazy. It's really awesome, but it's also causing a lot of damage, which means I can't really use that setting because where I'm at, there's really no way of procuring, reinforced push rods or anything like that. We only have the stock ones. But I am using sort of like a clone off-brand sort of push rod, so I will try to see if I can source like the original Honda engine push rod, but I doubt it would be any different because yeah, I mean, the quality difference is not that significant. So, yeah, so with the ignition timing, I mean, it's really great that, it's providing a huge amount of power boost, but it's like, hurting itself in the process, so I don't know. I'm hoping that I'll be able to make this work in the future, but right now it's just yeah, it's like very self-destructive sort of power gain. So yeah, I mean, if you guys got any suggestions as to what I can do to improve the situation, please let me know. But so far, I think yeah, without being able to buy reinforced push rods or anything, I don't think I'll be using this setting in the future. Maybe just for experimentation or whatever. Anyway, so that's it. I mean, it's a very simple video. Just want to share my findings with you, and yeah, I'll see you guys in the next one. Peace.